All right, formulas of linear acceleration. Super simple, basic journal entry, but valuable. So we're going to analyze. We have here a bunch of formulas that all contain, or one form or another have to do with acceleration. Da, 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 da. This one should look very, very familiar because it's the one we've been working with. We're going to analyze. So we have acceleration equals final velocity minus initial velocity divided by the change in time. The question is asking us to solve, the formula is set up to solve for acceleration. So over here in these columns, acceleration, that's the question. Final velocity and initial velocity are both present. Displacement is not present, but change in time is. So we're just going through and analyzing. What do we got? What do we not have? So change in time. That is the question in this formula. Final initial velocity and acceleration are present. Displacement is not. If you notice, this formula is just that one rearranged. Again, another rearrangement of the same formula. We have velocity. Final velocity is our question. Initial velocity is present, acceleration is present, and change in time, but not displacement. Our final derivation of this original formula, solving this time for initial velocity, that's our question. Final velocity, acceleration, and time are present, but not displacement. Now, displacement is now the question. Initial velocity is present. Time is present, and it's in there twice. And acceleration is present, but final velocity is not. Displacement is the question in this next formula. Final velocity is present, change in time, and acceleration, but not initial velocity. So if you notice, these two formulas are very similar. One, if you're missing the final velocity, you can use this formula to solve for the displacement. Or if you're missing the initial velocity, you can solve for the displacement. Final velocity is the question. Initial velocity is present, acceleration is present, and displacement, but not time. So if you don't know what the time is, for how much time something was moving, but you know the final initial velocities and the rate of acceleration and how far it went, you can solve for the final velocity. Okay? So it's kind of like pieces of puzzles. What you do know, what you don't know, what you want to solve for, and what you've got. So there's just analyzing these formulas. Displacement. That's our question. If I have the final velocity, the initial velocity, and the time, and don't know the rate of acceleration, I can still figure out how far the object went, because even though it's accelerating, because here we go. Acceleration, final initial velocity, the velocity is not constant. Okay? Change in time being the question. Displacement and acceleration, but we don't know the velocities, initial or final velocity, we can still figure out how much time it took it to go a certain distance if it was accelerating during that trip. So, just a quick analysis of the formulas that we will be using when we go through and practice the many linear formulas of linear acceleration.